And here we go. Cool. All right. So we get into linear graphs. And one of the ways to graph them is by using intercepts. So intercepts are given in the X form and the Y form. So you have an X intercept and you have a Y intercept. And there's a reason they're called intercepts, because if I were to draw a graph, so here's my X-axis, here's my Y-axis. Well, X-intercepts lie on the X-axis. And the coordinate will always be given as X, comma, 0. So whenever you have an X-intercept that's on the X-axis, the value of Y is always 0. And then Y-intercepts lie on the Y-axis. So they lie anywhere on the Y-axis. And if you have a Y-intercept, then that coordinate will always be known as 0, comma, Y. So whenever you're on the Y-axis, whenever you have a Y-intercept, the value of X is always 0, and you'll always have a value for Y. So X-intercepts on the X-axis, Y-intercepts on the Y-axis. And now when you're solving for X and Y-intercepts, so we'll use number 1 as an example. It says find the X and Y-intercepts of the following lines. So for number 1, if we want to find the X-intercept first, the first thing we're going to do is let Y equal 0. And the reason for this is because if you're finding an X-intercept, the value of Y is always 0. Okay, so that means we take 0, we plug it in for Y, and we'll solve for X. So that's what we're going to do here. So we're going to have 0 equal to negative 2x plus 9. So all we've done so far is plug Y in for 0, and now we're going to solve for X. So I will add this 2x to the left side, and you'll get 2x equal to 9. And then to solve for X, I'll divide by 2, and we will get that X equals 9 halves. So there is my X-intercept. And if we were to graph it, I would put it in coordinate form, such as 9 halves, comma, 0. Okay, so that's the X-intercept. Now, for the Y-intercept, you would let X equal 0. And once again, since you're solving for a Y-intercept, all your Y-intercepts lie on the Y-axis, meaning X is always 0. So this is why we let X equal 0. And what we do with that information is you plug 0 in for X and you solve for Y. All right. So you'll get Y equals negative 2 times 0 plus 9, and Y will equal 9. And there's our Y-intercept. And if I wanted to put it in coordinate form, it would be 0, 9. Okay. And that's how you find an X-intercept and a Y-intercept of a linear equation. All right. Any questions on that? Okay. Let's do it again.
Do we need to draw the graph for you?
No.
Okay.
Not for these ones. On this, we're just finding the X and Y intercept.
Okay.
Okay. Cool. All right. Let's do it again. So for number 2, find your X-intercept, Y-intercept. So X-intercept, you let Y equal 0. And then, oh, my Alexa's listening to me. There we go. Okay. And then you plug in 0 for Y. So you will get 0 equals 6 plus x. And this time to solve for x, it's just going to be easier to move that 6 over. So we subtract that 6, and you get negative 6 equals x. All right. And of course, in coordinate form, negative 6, comma 0. Okay. And then y-intercept. You let x equals 0, plug it in for x, y equals 6 plus 0, and y just equals 6. There we go. And 0, 6 would be your coordinate. All right. So that's not bad. Again, that's how you find an x-intercept and a y-intercept. And 2 more. So let's see. Next. For number 3, 12y minus 2x equals 6. All right. Find our x-intercept first. X-intercept, let y equals 0. And I'll have 12 times 0 minus 2x equal to 6. 12 times 0 is 0. So what we're left with is just negative 2x equal to 6. Divide by negative 2. And x equals negative 3. There's our x-intercept, which is going to be negative 3, 0. Okay. And then do a y-intercept where you let x equal 0 and plug in 0 for x. 12y minus 2 times 0 equal to 6. 2 times 0 is 0. So you get 12y equal to 6. Divide by 12. And 6 over 12 reduces to what fraction?
1/2.
1/2. Good. There it is. And our coordinate would be 0, 1/2. Okay, awesome. One more time. All right, 4. X-intercept, let y equals 0. 8x plus 5 times 0 equal to 17. You get left with 8x equal to 17. Divide by 8. And x equals 17 eighths. All right, and there it is. 17 eighths, 0. All right. And then y-intercept, x equals 0. You get 8 times 0 plus 5y equal to 17. You get left with 5y equal to 17. Divide by 5. And y equals 17 fifths. And our coordinate would be represented by 0, 17 fifths. Okay.
I actually have a question. I'm
What's
so
up?
sorry. So on number 1, you saw how, well, it's negative 2x plus 9 when we're doing the x-intercept one. And we divided by 2. Wouldn't we divide by negative 2 there too, or?
No, the reason it's positive is because I took this negative 2 and I added it to the right side. I mean, the left side. Sorry, the left side.
Okay.
So when I add it to the left, it becomes positive.
Gotcha. Okay. Thank you.
Yeah, good question. All right, so that's how you find x and y intercepts. Any questions on those 4? Oh, all right.
So if you have say a number there instead of 0, would you do it the same way, times it by, I guess, whatever that is, x, 2x Let me find one. Like where you had you just did the last one, 8x plus 5,
Mhm.
0. Now, if there was that was equal to 0, say with y equals 0, would that be like, would you times by that number? Say if there was a 4 there.
So say if it was like 8x plus 4 equal to 17 or something like that. Then what you would do here is you can only solve for x. So you wouldn't have a y-intercept. So you would only have an x-intercept for that one.
Ugh.
So basically here, we just input 0 to the y and to find the x, right?
Exactly. And then put 0 into x to find y.
Oh, okay, perfect.
Right?
So we don't need to worry about those other numbers, right?
Exactly. So to find an x-intercept, you plug in 0 for y and solve for x. And then to find a y-intercept, you plug in 0 for x and solve for y.
Oh, okay. Phew.
All right. Nothing crazy, right?
Mm-hmm.
All right, let's see what number 5 says. Sketch the graph of a line that does not have an x-intercept and a line that does not have a y-intercept. Okay, so remember, to have an x-intercept, you must cross the x-axis. So here, I'll draw this down here again. So if I was going to draw another graph, here we go, there we go. And this is the x-axis, there's the y-axis. So if you do not have an x-intercept, this means you do not cross the x-axis. So what type of line would we have if we don't cross the x-axis?
Wouldn't you have like a horizontal line?
Very good. If I have a horizontal line, does this line cross the x-axis?
No.
No. So this would represent a line that does not have an x-intercept. So this would be a horizontal line. Okay. So, and it could be any horizontal line, wherever you put it, as long as you don't put it on the actual x-axis. So a horizontal line can be a line that does not have an x-intercept. Okay, and to go further on it, horizontal lines, their equations look like this. Y equals some number, what's it good? I don't want to put x. Let's say y equals some number a, where a is any number. So if I drew y equals -2, that line would be down here. Or if I said y equal 10, that line would be somewhere up there. So that's what the equation for a horizontal line looks like. Y equals any number a. Okay, well that takes care of A. Now we want to take care of B. So let me draw this graph again. Here's the x-axis and the y-axis. And now we want to sketch a graph that does not have a y-intercept. So remember, to have a y-intercept, you must cross the y-axis. So we need a graph that does not cross the y-axis. What would that look like?
Vertical.
A vertical line. Let's just put one over here. Why not? This is a vertical line. Does this cross the y-axis? No, right? So this is a vertical line. And the equation for vertical lines is going to be x equals some number b. And again, that represents any number you want to put in there. So that's the graph of a vertical line. And that is the equation of a vertical line. So horizontal lines, y equals some number a, vertical lines, X equals some number B. And I guess what we're getting out of this exercise is that some horizontal lines do not have an X-intercept, and some vertical lines do not have a Y-intercept. All right. Any questions on those two? Okay. Then number 6, I'm assuming since there's no instructions, we're going to solve for Y on number 6. So let's go ahead and put that on those. That's funny. All right, we're going to say solve for Y. Okay, and I'll rewrite this equation. 5y over 2 equal to 10. How would I solve for Y? What could I get rid of first?
The 2
The 2. Good. How would I do that?
by multiplying it by everything, I believe, or just the 5.
Well, you can take that 2 and multiply it to the right side, right?
Oh yeah.
So if I do that, that will give me 5y equal to 20. And then I could divide by what?
5.
5. And y would equal,
I'm sorry, I was muted. 4.
4. Good. There you go. All right. Or,
So would we still write this like, oh, you're about to do it.
oh, no, go ahead. This is now not an X or Y intercept. This is just solving the equation.
Oh, okay. Gotcha.
Yeah. Because I think the purpose of this exercise, since we're looking at vertical and horizontal lines, we can now claim y equals 4 is now a horizontal line.
Oh, okay, I get what you're saying. So we would be able
Yeah.
to graph it like,
Exactly. You would just draw a horizontal line at 4
okay,
on the
thank
graph,
you.
if we had to graph it. Okay. So actually, let me state that this is a horizontal line. Okay, my other option was there's always the or. So you have 5y over 2 equal to 10. Remember, if you don't like fractions, we'll get rid of them. If I have a fraction of 5 halves, if I want to get rid of that, I would multiply both sides by the reciprocal. 2/5. And over here, cancel. You get left with y equals, and 10 times 2 is 20. 20 divided by 5 is still 4. Or take a 5 out, that's 1. Take a 5 out, that's 2. 2 times 2 is still 4. However you want to go about
I did it that way at first, and I was like, maybe I did it wrong, so I just left.
it. And you got it right. See, look at that. Okay, awesome. All right, and then number 7, that looks pretty straightforward. 8x equal to negative 16. We would divide by 8. And x would equal what number?
-2.
Negative 2. Perfect. Now, what type of line would this create? Good, a vertical line. If y equals some number is horizontal, then x equals some number is vertical. Okay, cool. I guess I should have put instructions on this one too. I don't like how that looked. It was like, hey, here's some equations. Do whatever you want with them. All right, there we go. Solve for x. Okay. Number 8. Oops. Write an equation of a line with the y-intercept 0, 5. Okay. So this is still working with the horizontal and vertical lines. So if we want to write an equation of a line with the y-intercept at 5, would I want to create an equation for a horizontal line or a vertical line?
Horizontal.
It would be
A
horizontal.
horizontal. Good, because horizontal lines cross the y-axis. And if you cross the y-axis, you have what intercept?
X intercept.
Well, if you cross the y-axis, you have a
Y-intercept.
y-intercept. There you go. So this says write an equation of a line with a y-intercept at 5. So our equation is just going to be, guess what? Y equals what number?
5.
That's it. Or, I mean, our answer could be infinite possibilities, but since we were working with horizontal lines and vertical lines, this makes much more sense, because if you guys seen this one before, y equals mx plus b, which is your slope intercept form, you can plug in that y-intercept of 5 for b, y equals mx plus 5. And then since we're just creating something, just plug in any number you want for m, and the solutions are infinitely many. So you can plug in 1, you can plug in 0, you can plug in 10, you can plug in 100, and no matter what, that equation will still have a y-intercept of 5. So that's actually pretty cool. So either one works. I'll just draw a little cloud there. There you go. Okay. Everybody good with this page?
I'm so sorry. You
What's up?
lost me just a tad. How did that correlate with what we just saw?
So which one, the green one, the purple one, or both one, or both?
The purple one. How
The
did
purple
the
one.
slope intercept?
Okay. So the reason I showed slope intercept form, because I don't think we've seen it yet in this class. You may have seen it a long time ago, but this number 8 said write an equation of a line with the y-intercept. Well, whenever you're given slope intercept form, B always represents the y-intercept. So all I did was plug in 5 for B. And then for the MX, I said, this is why I said the answers are infinitely many. You can choose whatever number you want for M, and your answer would still be correct. So no matter what number you chose for M, that equation would still have a y-intercept of 5.
Thank you.
If that makes any more sense. All right. Other than that, just stick with this guy. Because today is all about x-intercepts and y-intercepts. I think next class is all about slope intercept. Who remembers y equals mx plus b?
Me.
One person. Perfect.
Yeah, I remember it too. It's just I was like,
Did it last semester with that refresher course.
Okay.
Nothing
Good,
I'll
good.
ever forget.
One. Perfect. So good. We've seen it before. All right, cool. Well, now let's use the intercepts method, what we've been learning today. We're going to find the x-intercept, the y-intercepts, and we are going to use those to help us graph a function. All right, to graph a linear equation at that. Okay, so number 9, we're given 5x plus 2y equal to 10. Let's go ahead and find the x-intercept and the y-intercept, just like we've been doing today. So first up, x-intercept means you let y equal 0. And 5x plus 2 times 0, because we're plugging in 0 for y, equal to 10. 5x equals 10 because that 2 zeros out. Divide by 5. And x equals 2. All right. And here's where that coordinate form is going to be really, really handy. So since x equals 2, our x-intercept is 2, 0. So what you're going to do next is, since it's an x-intercept, you look at your x-axis and you're going to plot a point where you see +2. Is that going to be on the left side or the right side?
The right.
Right here. There you go. There's our x-intercept. We have it plotted. Now, we look for that y-intercept. For the y-intercept, you let x equal 0. And I'll get 5 times 0 plus 2y equal to 10. 2y equals 10. Divide by 2. And y equals 5. Okay. And put it as a coordinate 0, 5. Okay. Now, that's a y-intercept. It lies on your y-axis, and you're going to look for a +5, which is 1, 2, 3, 4, 5, right there. And if you're ever graphing by x-intercept and y-intercept, those are the only 2 points you'll ever need. So all we have to do now is connect them. Just draw a straight line right through them. And I'm pretty terrible with this drawing pad, but I'll do my best. Nope, that's terrible. All right, let me see. I just gotta go faster. Quick. You get it. It's supposed to be a straight line. One day I'll get really good at drawing lines on this drawing pad. Let's see, last attempt. Oh, I'm way off. Okay. Right. Let's see. I got this. Connect those two first, and then boom, and boom. All right. That's it. Not going to get any better than that. All right. Okay. Everybody good with that process? Okay. Cool. So x-intercept, y-intercept, fastest way to graph. Let's try it again. Oh, look at those fractions. 1/4 y minus 1/8 x equal to 1/2. Here we go again. X-intercept, you let y equal 0. So you have 1/4 times 0 minus 1/8 x equal to 1/2. 1/4 zeros out, and you get left with negative 1/8 x equal to 1/2. Okay, so we have to get rid of that 1/8. So we can divide by 1/8, or we can multiply both sides by the reciprocal. What is the reciprocal of negative 1/8?
8/1.
Good. So
Just
negative 8/1. Good. And we're going to make it negative so the x over here can become positive. All right. And if we multiply both sides by the reciprocal, cancel, positive x equal to, and then this becomes negative 8/2, which gives me negative
4.
4. Good. And our point is negative 4, 0. Okay, cool. Do it again. Y-intercept, we let x equal 0. 1/4 y minus 1/8 times 0 equal to 1/2. 1/8 zeros out. You're left with 1/4 y equal to 1/2. And same situation. Don't want to divide by 1/4. Let's get rid of that 1/4. So multiply both sides by what number?
4/1.
4/1. And on the left side, cancel, cancel. We get left with y equal to 4 divided by 2. That leaves me with 2. And we get 0, 2. Okay, let's go ahead and plot our points. -4, 0 is my x-intercept. So we look on the x-axis and right there. And then y equals 2, right there. And connect. Oh, I can do these. Look at that. I guess it's going the other way. I am not good. Maybe I have to turn my drawing pad the other way. All right, that line was much better than the other one. All right. So same process as the one above. Everybody good with that one? Thumbs. All right, got some thumbs. Okay, cool. What's next? More. All right, cool. 2y plus 1/4 x equal to -2. All right. So again, x-intercept, y equals 0. 2 times 0 plus 1/4 x equal to -2. 2 cancels out, 0's out, and 1/4 x equals -2. Okay. And once again, you could divide by 1/4 or multiply both sides by what number?
4/1.
4/1.
Yeah, right.
Or we can even just say, hey, 4 times -2, just multiply that to the right side, right? And x would be -8. And -8, comma 0. All right. Y-intercept, you let x equals 0. 2y plus 1/4 times 0 equal to -2. 1/4 zeros out. 2y equals -2. Divide by 2. And of course, y equals -1. 0, -1. Okay, excellent. Find that x-intercept at -8 on your x-axis. Find that y-intercept of -1. Oops, don't want that one. Of -1. Then fun. Can I go this way? No complication. Yeah, almost. Close enough. Okay. So I'm only good at drawing straight lines that way, not that way, or that way. All right. Okay. Next, same thing. All right. Number 12. 12y minus 2x equal to 6. So x-intercept, always let y equal to 0. And 12 times 0 minus 2x equals 6. 12 zeros out. So -2x equals 6. Divide by -2. And x equals -3. There we go. -3, 0. Okay. Y-intercept, x equals 0. 12y minus 2 times 0 equals 6. 12y equals 6. Divide by 12, and 6 divided by 12, 1/2. So 0 and 1/2. Okay. Plot your points. -3, 0. So 1, 2, 3 on the x-axis, -3, 0. And y is 1/2. So this is 1. And right there is right about there is going to be your 1/2. So y is 0.5. So we put that right there. Okay. And just connect. To the right. Down to the left. Okay, sweet. So everybody good with those examples. Find your x-intercept, find your y-intercept, plot them, and graph them. We all good?
For the y-intercept for number 11, you got -1, right?
Yes, -1.
Okay. Thank you.
Yeah. Okay. Awesome. Okay. Number 13. Same thing here. All right, so this, we can only solve for y on number 13. So there is no x-intercept on this one. So we solve for y here. I'll write this one out again. And I think we already did this one, right? 5y/2 equal to 10. And yeah, this was one we did already. We said to multiply by the reciprocal to help us solve for y. And cancel, 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 cancel. You get y on the left side. And 10 times 2/5, that's 1. That's 2. And 2 times 2 is 4. Okay. So we get y equals 4, which is what type of line again?
Horizontal.
Horizontal. Okay, so what we're going to do is we're going to start at y equals 4 right here. And we are going to go out to the right, straight across, and out to the left. That's it. Okay. And then for number 14, once again, we did this one already too. So 8x equals -16. We can only solve for x. There's no y-intercept. And you divide by 8. And x equals -2. Well, if the one above was horizontal, then this line must be what?
Vertical.
Vertical.
Vertical. Good. So what we're going to do is go to the x-axis, find -2, which is right there. And we are going to go straight up. And straight down. And that's how you graph your horizontal and vertical lines. Okay. Is that it? Yeah. So that is the X-intercept, Y-intercept method and how to graph them. So any questions on those guys? Let me check something. Modules, yeah, we're still a day behind, but okay. So today was just using the intercepts. Okay, awesome. Well, guess what? We're done for the day. So if you got questions, stick around. If not, I'll see you on Wednesday.
Thank you.
You're welcome.